Talking about the unit circle right now. Here is a diagram of the unit circle. It is defined as a circle on top of an XY axis with a radius of 1 unit in length, right? That means all of these lines that I'm drawing are 1 unit in length. Right, again, this is a circle which essentially has an equation of x squared plus y squared equals 1. Right? It's centered at the origin. It's got 1 unit in length, right? So what happens is that all along this unit circle, we see these points that I'm going to fill in. If I were to draw an angle like so with the initial side in the same location, and let's say an angle over here that intersects the unit circle at this point, then it would intersect the unit circle at a point of 1/2 comma radical 3/2. And what happens is that this 1/2 is actually, if these two lines form a 60-degree angle, that means that the cosine of 60 degrees is equal to 1/2, and that means that the sine of 60 degrees is equal to radical 3/2. So what the unit circle does is tells us the values of the sine and cosine functions at these particular angles. So let's look at a problem in web work that deals with this. Given an angle theta equals 13 pi over 4, first of all, to what quadrant does this theta belong? All right, so let's take 13 pi over 4, and let's use our conversion rate of 180 over pi to multiply this and come up with a degree measure. Divide by 4 to get 13 on top times 45, and this is going to equal 585 degrees. Right, so 585 is an angle measure that is larger than 360 degrees. So that means we can take and find a coterminal angle. Oops, that's a 585. Let's subtract out 1 full revolution of a circle, 360 degrees, and then we'll put us at 225 degrees. Now this is where we want to be, right? Essentially we want to take our theta, which started out as 13 pi over 4, and convert it into a degree measure that is between 0 and 360 degrees, right? This is because all our calculations will be based upon this happening, right? So again, 225 is a coterminal angle to 585. That means as far as trigonometry goes, they're exactly the same. So let's draw an angle that measures 225 degrees. Starts at 0, swings past 90, swings past 180, but doesn't quite meet 270 degrees. That's going to be right there. Numbering our angles starting from the upper right-hand side, we can see that our angle is in quadrant number 3. Okay? So let's find now the reference angle for theta. Let's draw a new diagram. And this diagram, we can focus on the third quadrant because we don't need to be in any other quadrant. Initial side, terminal side ends in the third quadrant. And we know that this angle measure is 225. Right, so where's the reference angle located? Reference angle is always located between the terminal side of the angle and the x-axis, right? Always between the two. So what I'm shading in red right now is the reference angle. And in the third quadrant, you can find a reference angle by taking your angle measure for theta, subtracting out 180 degrees. In this case, it's going to be a 45-degree reference angle. In radians, that would be dividing 45 by 45 to get 1, dividing 180 by 45 to get 4. that would be a radian equivalent of pi over 4 radians. All right. So this is our reference angle. Now the next thing we want to do, the next thing is find the point where theta intersects the unit circle. Now we can see from here that if we were to draw a 225-degree angle, right, starting at the initial side, swinging around to what says 225 over here, we can actually see that this angle is going to intersect the unit circle at this red point, this ordered pair of radical 2, negative radical 2 over 2, comma, negative radical 2 over 2. Let's actually build and show the work to get that ordered pair. All right, so a new diagram, again in the third quadrant. Let's draw our angle in the third quadrant. We can make this nice and large. What I'm going to draw now also is in red the unit circle, right? But just the third quadrant portion of that unit circle. And then let's put the ordered pair where it intersects in green over here. This is what we're looking for. Right now the unit circle tells us our values as cosine of theta, comma, sine of theta. Right, so this ordered pair over here is the cosine of this was 13 pi over 4. And the sine of 13 pi over 4. Right, but instead of using radians, we turn this into degrees. So we're actually looking for the cosine and sine values of 585 degrees. And furthermore, we were able to turn this into a coterminal angle. And now we are looking for the cosine and sine of 225 degrees. Right, that's what we have here. So from the x-axis and the terminal side of this angle, we can draw in whatever this color is, we could draw a perpendicular line to create ourselves a right triangle within that reference angle of 45 degrees that we calculated earlier. Right, this creates a 45, 45, 90 right triangle, which means that we can fill in the sides. The legs up here is 1, the leg down here is also 1, and the hypotenuse is equal to radical 2. These are the basic sides, the basic side lengths of a 45, 45, 90 right triangle. Thus, radical 2 is the hypotenuse, and we have opposite and adjacent, each equaling 1. Right, so now we're using a reference angle of 45 degrees. So not only are we not finding and using 225 anymore, we're actually using 45 instead. But this substitution here that we're using is not 100% direct. We were able to substitute 13 pi over 4 and use 585 directly. We were able to also use 225 directly instead of 585. But now that we're using 45 degrees, it's not quite the same. Because in the third quadrant, cosine is negative and sine is also negative. So opposite over adjacent using SOHCAHTOA, or just the SOHCAH part because we're only looking at sine and cosine. Opposite over adjacent is equal to 1 over radical 2, which is negative because cosine is negative. And sine of 45 is also actually equal to negative 1 over radical 2. Right? That's opposite being 1 and adjacent being 1 and the hypotenuse being radical 2. So this is our answer. And if we want to fully complete our answer, we can take negative 1 over radical 2 and rationalize that denominator to negative radical 2 over radical 4, which is equal to negative radical 2 over 2. Right, that's why you'll see some publications and some other worksheets and kinds of things put this answer as negative radical 2 over 2 instead of negative 1 over radical 2. And that's exactly what we see over here. Negative radical 2 over 2.